Morning, dear students.
Morning, sir.
So we have completed yesterday what are the different characteristics and the waveforms for a DIAC and TRIAC, how they will work, and the characteristics, VA characteristics, voltage characteristics we have seen in the last class. Okay, now how the phase control circuit is used by using a DIAC and TRIAC. So in the AC power controls, that is mainly the power control of the large amount of powers. So megawatts of powers, how can we control by using a track? So and also back. So and what are the input and output waveforms? Now we can see here. So the circuit is consists of a AC supply, okay, which is a power supply, and you have a two resistors connected in series R1 and R2, where R2 is variable resistors and R3 is a constant resistor that is connected to the diac, and the diac is connected to one of the terminal is connected to the gate of the track. Okay, and the capacitor is connected in series with the R1 and R2. Okay, so this will decides which one decides R1, R2, and C will decide the when the track will on, how much time the track will trigger on, and how much time it will be trigger off. That will be decided by this resistor as well as this capacitor. So combination of these resistors and capacitor will decide the how much time will be track will be turned on and how much time will be turned off. So that is the firing angle. The firing angle of the firing angle of the track can be decided. Okay. So what is the major purpose of the DIAC? So in order to DIAC is already discussed. So DIAC is called a gateless track which is used to trigger on the track. Correct or not? So DIAC main purpose is to trigger on the track. And the R1 is the constant resistance and R2 is the variable resistance and R3 also a constant resistance. Okay, so when R2 equal zero point 0.1 R1 or R2 equal to 0, then what will happen? So R2 equal to 0 means what R1 is present. So R1 is present means R1 into C. So R1 into C is the time constant that will given to the diac, and diac will trigger on the track. Okay. So, and we have a how the firing angle can be varied means the firing angle can be varied from 0 to 180 degrees, but practically it is only 10 degrees to 170 degrees only. So, what is the firing angle? I already discussed. What is the firing angle? The it is the angle at which the device, the power electronic device will turn on. So here that power electronic device means time. So you can generalize the definition is what is the firing angle means the angle at which it will starts conduction. It will start the conduction means here the track will start the conduction. Okay. So we can change the R2 resistance. So we can change the R2 resistance means you can change the time constant so that you can also change the firing angle. That is means that you can able to change the power control. Correct or not? How much time you can able to turn on or conduction of the load voltage. So that is the AC power supply will be on to the load. So how much time you can also off the power supply to the load. So that is also considered by using this track. Okay. So this is the and you can vary by using a time constant. So what is the time constant means R into C. So R into C you can call as the time constant. So you can change the R2 value. So R and C value changes, that is time constant changes. So time constant means subsequently the firing angle of the track can also be varied. Okay. So when R2 equals to 0, what will happen? The R1 into C is the charging time of the capacitor R1C. So it will charging actually the R1C time constant value, which will, on which time it will capacitor will charge, and the voltage will develop across the capacitor now given to the diac, and the diac will be given to the directly given to the gate of the triac, and it will be turned on. So how much time it will be decided when R2 equal to 0 means R1 into C only. Okay. So and whenever the R2 is increased, that means R2 is exist. Exist means it will the time constant is changing. So R1 plus R2 into C now. The time constant is R1 plus R2 into C. So when R2 is small, the charging time is small, and the firing angle of the track will be small. Okay, correct or not? R2 only R2 is present means, so what will happen? Charging time is less. So firing angle of the track also less. So whenever the value is increased, R1 plus R2, so now it is increased. The R2 value is increased. So what will happen? It is having a high charging time. Correct or not? So firing also more than the conduction time of the track will be less. Okay. So what is that? The track will be conduction time of the track will be less. So if you see here, so this is the input supply. You have a what is the you can see the power supply. So VC is the charging time of the capacitor, and V0 is the output. Okay, V2 is the threshold voltage. Okay, or triggering voltage. So what is the triggering voltage? The track can be analyzed to this. So whenever it is on, the track will be on. So what will happen? So whenever the track will be on means so that is charging time. So if it is conduction state. So when it is conduction state, so starts will be there. When the firing angle alpha is on, so it will be starts conducting. Correct or not? So this is a conduction angle. 180 minus alpha is called as a conduction angle. So whenever the time at the alpha your starts means, so after that 180 minus alpha is the conduction angle. Okay. So alpha after alpha it will starts conducting. Okay. So whenever the capacitor is charged and the pulse is generated at the track. So triggering pulse is generated here. You can see here. So charging time increases and the same it can be appeared at the track. Or VTV is the triggering pulse or track at the voltage at the track. So whenever it is trigger on, then it will the conduction angle. You have a alpha. So alpha is there. So after alpha, your the output voltage will raise. That will be conduction. So that is the reason it is a conduction angle. So what is the conduction angle? Pi minus alpha or 180 minus alpha. Okay. Next, what will happen in that period? What will happen? Now the track is on state. So what is the on state means? Zero voltage. So on state means is short circuit. It is zero voltage. So after pi means what is the off cycle? After positive off cycle, what will happen? It will turn the VC supply, VS supply is the it will turns its direction. That means goes into a negative direction. In the negative direction, what will happen? In the negative direction also it will start conducting. Why? Because it is track. So if your SCR is there, you can't able to turn on because that SCR will be off in the reverse bias condition. So, but in the case of the track, it will also turn on the track, so it will also conduct. So how much time it will take means, so it is alpha. After again you have a after pi. After pi means it is zero. After zero it is goes into negative direction. So that means after alpha. So after alpha, so firing angle that means it have a some trigger pulse at the track or your at the end of the gate pulse of track. So what will happen? It is having a some gate pulse like this. Okay. So what will happen in that period? So after alpha, again it will start conducting. So how much time it will there? Pi plus alpha. Because after pi means it is pi plus alpha. So here pi minus alpha, this is pi plus alpha, it will starts conducting again. So this portion of cycle it will conduct. This portion of cycle it will conduct. So again same thing it will repeats. So after alpha you are generating a triggering pulse. So 2 pi after 2 pi plus alpha or after 2 pi plus alpha it will conduct again in the negative of cycle it will off in this period. V0 will be off because in the alpha period it will generate some trigger pulse. So after trigger pulse you have a 3 pi plus alpha. 3 pi plus alpha it will conduct here, but it is in the negative direction. Like this you will get the pulses, output pulses, the V0 output voltage of your track or at the load. Okay, is it clear or not? Very simple to understand. How to control the AC voltage? Vs. So what is the Vs? Vs is the input supply voltage. It is our power supply. That power supply how to control over the load. So in the direction where you want to only on, you can on. You can where the direction you want to off, you can also off by using a triac. So that is the reason you can, it is called as the phase control. The phase of the signal, how much phase voltage will be on, how much phase of the circuit will be off. So that is the reason it is a phase control using a DIAC as well as track. So why only you can't only track directly, you can't able to connect means it should be on. It should be on by using a DIAC only, because DIAC is used as a triggering device for the track. And the tag, one of the terminal you have to connect to the gate of the track, and one of the terminal you have to connect to the constant resistor R3, and the combination of R1 R2 and the series combination with the C, which will decides the how much time it will be on and how much time will be off. So that is time constant. Whenever it is R2 is 0, so time constant is less. So time constant is less means what will happen? Alpha is alpha less. So alpha is less means the conduction angle is less. So the conduction angle is less. So what will happen? It will trigger on the DIAC, that will be given to the track, and it will be how much time it will be there. That time it will be half, and as well as and the conduction will start in the pi minus alpha state. So is it clear? Alpha is the firing angle means pi minus alpha is the conduction angle. So next what will happen after pi? You have a pi plus alpha is the conduction angle. After 2 pi you have 2 pi plus alpha is the conduction angle. So where alpha is the firing angle, there you can start the conduction. So alpha means that the track will trigger on that state where the track will trigger on. So if you seen this waveform, you can easily observe. So due to during between a 0 to alpha, you have raised some triggering pulse. So there your track is on. So what will that after alpha the track will on means that it will on means it will be zero voltage. So there alpha to pi it will charge, the capacitor will is on state, and the output will be conducts. So output will be this much, output will be conducts. So this is the conduction angle. So after pi you have some again other pulse is generated. So which is at the track, this is pulse, negative pulse. So at that state it V naught is 0, and the pi plus alpha it is conducting, and the VT will be off. That means the voltage short circuited, V naught is 0, VT is 0. Okay, so whenever VT is conducting, then VT is conducting means V naught is 0. Whenever V naught is conducting means VT is 0. Okay, you can observe here. So depending on the this alpha values, so that alpha value decided by charging and discharging of the capacitors, and the R2 value. So because the R2 increases, the time constant is increases. So alpha will also increases, and the conduction angle will decrease. So like this, we have a power control, AC power control using the DIAC and TRIAC as well as input and output waveforms. So Vs is the input and V naught is the output waveform. Vc is the charging time, the capacitor voltage, and the Vt is the triggering voltage or TRIAC voltage. Okay, is it clear, all of you? Is it clear or not? Are you able to understood?
Yes, sir.
So what is the alpha? What is alpha? Alpha is the firing angle. So what is the firing angle? The angle at which the track trigger on. The angle at which the track or the device will trigger on. So what is the conduction angle? What is the conduction angle when R1 is R2 is 0? Whenever R2 is 0, the conduction angle is 0 to 180 degrees. So and the triggering angle range between 10 to 170 degrees only in practically. Actually it is 0 to 180 degrees. It should vary, but practically if you see the triggering angle will be 10 to 170 degrees. Okay, that means the firing angle, actually you want to totally you want to conduct this period, you 10 to 0 to 180 degrees, but practically it is not possible. Only it will conduct after 10 degrees to 170 degrees only. Complete cycle you can't able to generate or trigger. Okay, so this is the your phase control using a DIAC as well as TRIAC. So you have some important specifications of power electronic devices. So by the manufacturer data sheet, if you see, so there are some specifications you can see in your books. Okay, also you can observe here. So some ratings also there, some types of devices. So SCR. So at least you remember this device names. So MCR 106, MCR 115, C 106A, TY6004. They are the some device, SCR device. So what is the example for SCR? You can say MCR 106 is the example for SCR. So MCR 115, C106A, TY6004. They are the types of the devices of SCR types. Okay. So and track device. What are the track devices? You can say Q44, 2N6157. MESC 228 to BT136. This is the more majorly used track device BT136. BT136 is the track name. So if you have any device which is specified as BT136 means it is a track. Okay, BT136 mostly used in the all projects, major projects they will use BT136. So power MOSFET, so power BJT or power MOSFET, you have MPM6 and double five, 2N6762, 2N6760, 2N6758, 2N6757. So 67 means a series of MOSFET, power MOSFET. Okay, you remember like that. So what are the some VDS, ID, IDS, PD? PD means what is power dissipation. So TC is the junction temperature. So at 25 degrees Celsius, how much values of this? Okay. So you will see in your some manufacturer data sheets. So this is you have to remember something for device names at least. MCR 106. What is the example of SCR? So MCR 106 is the example. So TY6004 also. So like this. So and 2N6157 BT136 is the example for track. So and 2N67 series is the power MOSFET. Okay. 2N6762, 2N6760, 2N6758, 2N6757. They are the examples for 5 power MOSFET and the specifications. So you have to remember. So as well as UJT. UJT also some specifications for maximum rating at 25 degrees Celsius. So you will see the names of this UJT is 2N626. So 2N26 series is the UJT. So 2N2646 and 2N2647 MU110. Okay, they are the examples of UJT and their specifications also you can observe. So what are the major 6 important applications of power electronic devices? So directly they will ask list 26 important applications of power electronic device. Means all power electronic device if it comes. Either it is a SCR, maybe TRIAC or DIAC or SUS, SBS, anything. It will a major application they will use. So major application is battery charging. So battery charging is used. SCR is used for the battery charging. TRIAC also used. DIAC also used. Energy emergency of lamp circuits or dimming circuits. Lamp dimming circuits or emergency lamp circuits. Burglar alarms. Burglar means what is theft. So whenever the theft is occur, they will blow the alarm. They will give some alarm. So that burglar that is called a burglar alarm. Burglar alarms, light dimmer circuits, UPS, switched mode power supply, SMPS, e-cars, electrically operated vehicles, e-vehicles you've seen nowadays the vehicles you are observed is the electronic vehicles only because they will charging with the electricity. Okay, so e-cars, air conditioning units, AC, personal computers, television sets, washing machines, seeing machines. Seeing means you know. So what is seeing? Seeing means what? stitching on. Okay, electric door openers. So if you see in the where security purpose, so security guards they will used in the shopping malls before entry, and that doors operated by electricity, that is the electric door openers. So there also you will have this type of power electronic devices. So telecommunication networks, water level control circuits, automatic operated electric ovens, radars. So they are the some important application. Ultrasonic generators, hand power tools, elevators, paper mills, cranes, display boards. Okay, so we have some examples or applications of the power electronic devices. So if you've seen specifically the SCR, so common areas of application of SCR are relay control, series static switch, phase control system, battery charging, temperature controller, single source and emergency lighting system, regulated power supplies, RPS, speed control of DC shunt motor, choppers, inverters, cyclo converters, protective circuits, heater controls. Okay, so choppers means DC to DC converters, inverters means DC to AC. So AC to AC, DC to DC, AC to DC to AC. So AC to AC. So there are some circuits. They are called the converters. So mostly these converters are used by the SCR. So SCR is used in this type of converters, as well as your regulated power supplies, as well as we have a heater controls, phase controls, so relay controls, everything we have a SCR. So there are some examples you have to remember at least six. So you have to write these exams in part A. They will mostly ask. So in the 3 marks question, they will ask list out the six important applications of SCR or power electronic device. So tell me any six applications, any one of you. చెప్పండి. పవర్ ఎలక్ట్రానిక్ డివైస్ అప్లికేషన్ చెప్పండి. హర్ష, స్నేహ, చెప్పమ్మా. వైష్ణవి,
Sir,
చెప్పు. అప్లికేషన్ చెప్పు ఒక సిక్స్.
battery charging circuits,
ఓకే.
emergency lamp circuits,
ఓకే.
personal computers,
ఓకే.
television sets,
ఓకే.
radars,
ఓకే.
cranes,
క్రెయిన్స్.
electronic door openers,
ఓకే, రైట్.
washing machines,
ఓకే.
television sets.
ఓకే. E-cars or e-vehicles. Okay. Cranes, you have relay controls, power controls, phase control circuits,
Display board.
converters. So cyclo converters, you have the choppers. Okay, these are some examples and applications of the power electronic devices. So, so this is the today class. So I will wind up this today. So just you have to uh, thorough with this up to now. You have to revision. You have to take revision every day so that you will have easy to learn. Okay. All right. Thank you. Thank you all. Bye.